In this last screencast of our metal journey, or our metal section, we are going to talk about alloys. Now, I want to remind you, we've talked about this before, but I want to remind you that alloys are solid, homogeneous mixtures of two or more metals. Right? Now, why would we be interested in alloys? Well, alloys give metals more desirable properties compared to the individual metal. Right? And so what are some of these properties that are more desirable? Well, a lot of times alloys are harder or less brittle than the individual metal. They have higher or lower melting points, depending on the depending on what you're using the alloys for. A higher melting point may be more desirable, or a lower melting point may be more desirable. They are less susceptible to corrosion, and they are less expensive. Okay. I have a picture of Iron Man here, and we in pop culture we see kind of these references to science, and so we have Iron Man, and he's got his suit, and you would assume it's iron, but iron doesn't have a lot of desirable properties for a suit. Iron a lot of times will rust. And so if you listen to or watch the movies or read the comics, his suit is made out of nitinol, which is a nickel titanium alloy, right? Which has a lot more desirable properties than, say, an iron suit would. Particularly, it's less corrosive. So let's talk about places that we've seen alloys historically. About 5000 BC was the Bronze Age. And so one of the things that historians think is that the earliest alloys were probably formed by accident, right? So bronze, when we talk about this is a combination of copper and tin. Okay. And so if you go to museums, a lot of times you will see bronze tools or bronze weapons. So this is an example of an Egyptian dagger with an ivory handle. So it's bronze here and ivory there. That's in the Louvre in Paris. This is a bronze sword from the British Isles, and it's about from the second millennia BC. And so you'll be able to see some things like this when you go through museums. You'll also notice that there will be bronze sculptures. This is Perseus with the head of Medusa. And here is about the date of that. Now, a few things to think about when we are using bronze or metals to make sculptures. Bronze is tougher. As well as more easily melted and cast. And it's less susceptible to corrosion than pure copper. So if we think about the Statue of Liberty, that is pure copper, and it's already started to corrode. It's turned that green. Right, and we think about this particular sculpture, you can see that there is a little bit of green corrosion, but it is much less than if it was pure copper. There are over 100 different copper alloys available today. And we are going to explore copper more in the lab when we talk about making copper patinas. Okay. Now, there is another, there's a brass alloy called new gold. Now, when we talk about a brass alloy, brass is copper and zinc. Okay, so when we talk about brass, that is a mixture of copper and zinc. And so new gold is a brass alloy that you can see and buy today. It's a lot of times used as a jewelry sheet metal, right? And it's also used as a decorative embossed metal. Right, so you can see this sometimes in light fixtures here. This would be an example of a light fixture, and this is just a sheet of it that could be used for jewelry. It is a misnomer that it's called new gold because there is no gold in it, right? It's just copper and zinc. So that is a brass alloy that we see pretty frequently. Another use of alloys are solders. Solders are used to join metal together, so different metals together, and it relies on the capillary action of the melted metals, right? And so when we look at this, if we are trying to solder a metal, we would have our base metal here, and then we would have our solder here, okay? And so again, it's used to join metals. We see it a lot of times in jewelry in art. So jewelry solders are broken into two different categories. The first category are hard solders. And these melt at over 1,000 degrees Fahrenheit. And then you also have soft solders. And these melt at under 1,000 degrees Fahrenheit. You can look here and see the different amounts in some of the jewelry solders. A lot of times they're based on silver, copper, and zinc, right? And one of the things that we can do is we can compare the flow point. So this would be the temperature at which the metal is flowing and ready to solder. Pure silver, pure copper, and then zinc, and there just was an extra space in here, so we'll take that out. Right, and so what we see here is as we adjust the ratio of silver, the flow point will increase, right? So we go from 65 to 75, the flow point increases here, but it's still less than pure silver, which is right there. Now, other metal alloys that you may have run into, memory wire is a really fun metal alloy. If you want to watch memory wire, I have a YouTube video here for you. This is also a nitinol alloy, right? Which we already talked about is nickel and titanium. It was discovered in 1962 by naval researchers. Right? And so how it works is if you have cold nitinol, right, you can twist and deform the crystal structure really easily. So the crystal structure is deformed, right? So like if we had the wire and this was, we could twist it and we could deform it. And think about a paper clip, right? You twist it and bend it and all of those things. Then when you heat it up, it remembers its original shape. That's why it's called memory wire. And the crystal structure is more rigid, right? And so it goes back to a linear wire like it was before. So when it's cold, you bend it, you heat it up, and it will go back to its original shape. If we think about that paper clip, you can bend a paper clip, but you can't really do much to get it back into its original shape. Now, this has a variety of uses. It's used in the deployment of space antennas. It's used pretty frequently in robotics, right? And then a lot of times it's used in thermostat controls. Right, so great uses for kind of this alloy. Now we can also have precious metal alloys that we see in jewelry. Gold alloys are a really good example of a precious metal alloy. And these are measured in carats. And 1 carat is 1/24th part. So if you have 24 karat gold, that is pure gold, right? If you have 18 karat gold, right, it is 18 parts gold, right, and 6 parts copper. Okay. If you have 14 karat gold, it is 58% gold, 24% silver, 17% copper, and 1% zinc. Okay. If you have 12 karat gold, it's just 50% gold. And then if you have 10 karat gold, it is just 42% gold. Now, so maybe you're like, well, why would we mix anything with gold? Well, gold itself is very, very soft. So if you have pure gold jewelry, it's very likely to bend or ding or be misformed as you wear it. And so by having a alloy or mixing other metals in, it makes that jewelry a lot more robust and last longer. Now, we also have silver alloys. So the silver alloy that you'll see a lot of times stamped on jewelry is sterling silver. And this is 92.5% silver and 7.5% copper. We can have coinage metal. So if you think about all the coins and the metals that look silver, a lot of times that's 90% silver and 10% copper. Dental silver. So if you've had silver caps, right, that is 60 to 70% silver and 3 to 6% copper and 25 to 29% tin, and then generally about 0.2% zinc, right? And those just, the percentages there vary depending on where that dental silver is made. You can also have nickel, silver, and German silver, which is an older term. And just like new gold, these are misnomers. They contain no silver, right? They instead are 20% nickel, 60% copper, and 20% zinc. Right? If you have nickel coins, right, these also contain no silver. Right? So this would be like our nickels. They're 25% nickel and 75% copper. Now, so we're on the topic of coinage metal alloys. Let's talk pennies for a second. Right? If you have a penny that is pre-1982, those are copper. If you have post-1982, they are 2.5% copper and 97.5% zinc. If you have quarters, these are 91.67% copper and 8.33% nickel. If you run into a golden dollar, okay, these are 88.5% copper, 2% nickel, 6% zinc, and 3.5% manganese, and they contain no gold, right? So they're called a golden dollar because they have that kind of gold color, but they don't contain any gold. One of the things when we talk about jewelry to be aware of is a lot of people have nickel allergies. This is a contact dermatitis, and it can develop at any age, and it just comes from wearing like rings or earrings or watch bands or handling coins. It's just irritation when exposed to nickel. So if some people can't wear alloys that have nickel in them, and that has to change the type of jewelry that they wear. Sometimes bank tellers will develop this from handling coins. Now we're going to end talking about some of our ferrous metals and alloys. Ferrous is just another word for iron. So these alloys contain the element iron. Right? Iron is most often found as ores, and that means it's mixed with other things. So a really common ore is iron oxide. Ores, and you can have different ones. You can have hematite, which is Fe2O3. You can have magnetite, which is FeO times Fe2O3, or is sometimes Fe3O4. Right? You can have limonite, which is Fe2O3 times XH2O. And so I said times, but we really use a dot here to say, hey, look, it's got a certain amount of water molecules that are associated with it. This is called a hydrate. Right? And so that X variable there can vary. Sometimes it's 3 molecules of water, sometimes it's 2, so that's why we just use a generic X. These can also be found as iron sulfides. And if they're an iron sulfide, they're called pyrites. And they're like Fe or FeS2. And here are some examples of what those metal alloys look like. Historically, we talk about the Iron Age. This was approximately 4000 BC, Egypt. It was concurrent which means at about the same time, with the Bronze Age metallurgy. And again, where we see this a lot of times in art museums are the display of weapons. So weapons were made out of iron. You can see the Kirkborn sword and Viking swords here. So that's where we would see some of the iron there. Other common ferrous metals are wrought iron. Right? So like blacksmiths make, this is an example of wrought iron. There's almost no carbon content. It's very tough and malleable. So it can be designed and bent in a lot of different ways, ductile. And it's easily welded. Right? And so that's used a lot of times for decor on buildings. It is easy to hammer and heat and be worked with. The other type of ferrous metal that we run into pretty frequently is cast iron. Right? It's an alloy that contains more than 2.1% carbon. So it has more than 2.1% carbon. This, by contrast, has almost no carbon. Right, so both of them are iron alloys, but they're defined a lot of times by the percent of carbon that they have. And that increased amount of carbon does make this very brittle. So if we think about South Pittsburgh is one of the places where cast iron is made. The iron is cast into different shapes. If you have ever cooked or worked with cast iron, it can get brittle over time. And then once it's broken, you have a really hard time trying to fix it. So a lot of times once it's broken, it's done. You also don't wash cast iron because if you wash it, it will rust unless you dry it really rapidly. So like you would never wash cast iron in a dishwasher. You would always gently hand wash it and then make sure you dry it really, really well so it doesn't rust. And the last ferrous alloy we're going to talk about is steel. Steel is used a lot of times in buildings. It's an alloy of carbon that contains 0.15 to 1.5% carbon. It's an alloy of iron that contains 0.15 to 1.5% carbon. Other metals are added for their specific properties of what people are interested in. Examples of other metals that can be added are like molybdenum or titanium to help improve the properties. And again, lots of steel is used in construction. So this ends our Module 5 Part 1 of metals. We now are in the next part, gonna talk about some of the compounds that metals can make, and then we're gonna talk about chemical reactions.